Hello guys, in this video we will talk about the types of pre-stressing. First pre-stressing is concentric pre-stressing. Concentric pre-stressing force applied along the neutral axis, causing a uniform compression in the concrete. So concentric pre-stressing rarely used in a beams or slabs as they primarily experience bending. As they primarily experience bending moments. It's more applicable in members like tied columns or straight members under pure compression. Eccentric prestressing force away from the neutral axis. This eccentricity introduces both compressive stress and a bending moment in the member. The pre-stressing force is offset from the center, resulting in an internal couple that resists bending. Here you can see a concentric pre-stressing. As you can see, let me highlight. These are the forces. Okay, these are the forces that causing a pre-stressing. As in reality there is a reinforcement addendum which is pre-stress, and this is the resultant force which is causing a compression force. So P applied at center, so the stress distribution will be uniform. Yes, definitely. When a force P is applied at neutral axis, the stresses will be uniform. Okay, this is initial condition when there is no external load. Okay, this is a condition one where there is no external load, so the stresses will be uniform. Okay, uniform stresses uh, minus P by A. Okay, uh, let's let's see when there is external load. Okay, then there will the uniform stresses plus stresses caused by the external loading. Here you can see a compression minus mc by I, and there is a tension plus mc by I. Okay, so extreme fiber stresses ft is equal to minus p divided by a minus mc divided by I, and extreme bottom fiber, this is FB extreme bottom fiber and FT extreme top fiber. So we calculated the extreme stresses in case of concentric pre-stressing. Now uh, let's see eccentric pre-stressing. In eccentric pre-stressing, when the ducts placed below the neutral axis, here you can see a reinforcement or a straight wires placed below the neutral axis addendum. Then how can we formulate this? So let's talk about a column which is concentrated with eccentric force, which is concentrated with eccentric load uh, at a distance e. So how we replace this force with the m is equal to pe? We place one force here. We place one force here and one force here. After that, we just replace we just replace these two forces causing a couple. So we replace this with moment m is equal to pe. Okay, and this p remains. Okay, let me highlight it. So similarly, in the case of beam with eccentric loading or pre-stressing force, we will get a P on neutral axis and a moment m is equal to Pe. So This is uniform stresses caused by this P. This is uniform stresses caused by a force or a load P, a pre-stressing load P. And this is stresses caused by that by that movement which we replaced by a couple. Okay, so this movement is producing a tensile stresses at top and compressive stresses at bottom. Okay, therefore there is a plus sign on top and minus sign on bottom, and this is the resultant resultant condition when there is no loading. And there is no loading, okay, they are just plus and minus. When there is external loading, then the final the final equation we get is this: just mc by I, we just add it and minus it, because mc by I is compressive stresses at top due to external loading, and tensile stresses uh, caused due to external loading at bottom. So here there is a final equations. So this is the two types of concentric precessing. Let me explain it with my other notes. Okay.